I have opened the monkey data set, which is a really lovely little article. It's quite old. Is it quite old? I think it's quite old, but you can go and read it. It's quite fun. So these are the monkeys. These are the years they have been service monkeys, and these are the number of tasks they can perform. So the question is, can we predict the number of tasks a monkey can perform based on the years of service from this data set? So I've got the graph there, but let's go through the process of very quickly drawing it. So we've got our scatter plot. The variable we're trying to predict, or the outcome variable, or the dependent variable would go on the y-axis, so that's the tasks. And the explanatory variable, or the independent variable, would go on the x-axis. So let's have a look at this. Now, we don't have a lot of data points here, but we can still fit a line. So if we go to the add fit line at total, is that going to pop up with a little hint? There it goes, add fit line at total. By default, it will add a straight line, and we can see here, well, hopefully you can see on your version if this, because this font is tiny, the R squared is 0.474. So that's saying we can explain about 47% of the variation in the number of tasks performed simply by the years the monkey has been in service. Now, hopefully you're looking at this going, I don't think that straight line fits very well. And I would agree with you, I don't think that straight line fits very well either. So let's try a curved line. So we'll try a quadratic. And it's not perfect, but it is better. So the R squared is now 0.575. And the way a quadratic works is it just adds an extra term into the equation, and that's the years squared. So if you remember your high school math, your quadratic is the x and the x squared term with the constant term. So you can do the regression analysis for a quadratic equation fairly easily. You just need to add in that years squared variable. So if I go to transform compute, and we want, let's just call it y2 for years squared, and then we'll say years times years. Okay. And now we get our years squared. So if we run the regression equation from here, our dependent variable are the tasks performed, and the independent, we put both of them in, years and years squared. And you can see that now we have 3 terms in the model, and that's our R squared. Where is it? It's here. And that should be the same as this equation here. So we're not really going to go into fitting curves a lot, but I thought this might be of interest for those people who do remember their high school math and are okay with it, that if you do have a simple curve, that's actually not too hard for you to analyse at this stage either. And we would still save the residuals and do that residual analysis for this as well.